Today involves some DOM spelunking for a web scraper and tackling a couple of LeetCode problems. Sometimes the simplest sounding problems need a careful approach. Let's dive in. This is day 37 of coding every day until I hit 1K subs. Today I worked on a new web scraping project and did some LeetCode. Started a new utility project today, a JavaScript snippet to extract song info from YouTube music playlists directly in the browser. This involves web scraping techniques, specifically selecting elements from the document object model, DOM. Here's the basic idea outlined in the README. The main challenge is that it's quite fragile. Any UI update from Google could break the selectors. The usage is straightforward. Load the playlist, scroll down, open the console, paste the script, and hit enter. But the limitations highlight the nature of this kind of scraping. It relies heavily on the current structure and needs manual scrolling to load everything. Here's the core JavaScript snippet. It defines CSS selectors to find the song rows, titles, and artist names. It then iterates through the found elements, tries a couple of strategies to grab the artist, looking for links first, then fallback text, and formats the output. It's essentially DOM manipulation to pull out the text content we need. Also did a quick update related to the scripting for this YouTube series itself, just saving some progress, likely involving minor tweaks to the backend scripts that help automate parts of the video creation workflow. Practicing Python scripting for automation is always useful. Alright, let's switch gears to LeetCode. First up is problem 1128, number of equivalent domino pairs. Spoiler alert incoming if you want to try it yourself. The goal is to count how many pairs of dominoes are equivalent, meaning they have the same numbers possibly flipped, like 1, 2 is the same as 2, 1. This solution uses a frequency counting approach, with an array acting as a hash map. It normalizes each domino pair by always putting the smaller number first, creating a unique integer key, from 11 to 99. By iterating through the dominoes, it counts occurrences of each normalized pair. For each domino, it adds the current count of previously seen identical normalized dominoes to the result, ret plus equals numVal, effectively calculating the new pairs formed. This achieves oxygen mononitride time complexity as we iterate through the list once, and O1 space complexity, because the frequency array num has a fixed size, 100. Next problem, 3536. Maximum product of 2 digits. Spoiler alert again. This one asks for the maximum product you can get by multiplying any 2 digits within a given positive integer n. We can use the same digit twice if it appears multiple times. Okay, had a few attempts on this one, but the final approach is straightforward. The core idea is that the maximum product will always come from the 2 numerically largest digits present in the number. This refined solution converts the number to a string, extracts the digits into a list, and sorts them in descending order. The maximum product is then simply the product of the first 2 elements in the sorted list, which are the largest 2 digits. This approach has a time complexity dominated by sorting the digits, which is OD log D, where D is the number of digits in n, and requires OD space to store the digits list. We handle the single-digit case by assuming the digit can be used twice, though the examples focus on numbers with at least 2 digits. And that's it for day 37. A bit of web scraping and some LeetCode practice. If you enjoyed the video or found it helpful, please hit the like button and subscribe if you haven't already. Let me know in the comments if you've tackled these problems or built similar tools. And if you'd like to support the channel further, you can head over to buymeaboba.com, link is in the description. Thanks for watching, see you tomorrow.